Hey everyone, today we'll be talking about DataBridge. DataBridge is a powerful document processing and retrieval system. It can be used for making knowledge management systems for your AI apps. It allows you to ingest multimodal data, be it PDFs, plain text, images. It allows you to search over those documents using a query API and pass it as high quality context to an AI completions model. It is super modular, so you can swap out different components very easily. What we'll start with is a complete open source version and see how we can, instead of using Llama 3.2, put in, let's say, GPT-4 Turbo or something like that. So let's get started. We'll jump into the installation guide. Let's go to installation. By the way, all the links will be linked in the show notes for YouTube, so you can easily refer to those and jump to those. Let me just copy the clone command. And on my terminal, as you see, I'm already on the desktop. The repo has been cloned. Now, let me cd into DataBridge core, and let's start a VS Code server for it. Let me use cursor. Awesome. It's super easy to get started. I think the only prerequisites are you need to have Docker installed on your machine and have an Llama server. We won't be directly using Llama. We'll be using Docker to use Llama, but our installation guide has options if you want to use your own Llama server. The first command we need is a simple Docker compose up build. All right. So it says that I don't have a .env file. Uh, Let me just copy my example env and start an env file. And then when I start Docker Compose up, it should build. In the background, it pulls in the required models from Llama, starts the Llama server. It also creates the necessary tables, user permissions, the vector store, etc. for Postgres and starts everything. So as you can see, we have a server running on localhost 8000. Let's jump to the fast API server and see if we can see stuff. Just local 8000/docs. And there you go. We have a health check, readiness checks, basic functions like ingest text, ingest files. We can retrieve chunks, docs, and we can also use a completion model to query the API. The starting point for DataBridge is the databridge.toml file, which shows how everything is set up. So our API is hosted at localhost 8000. We have some authorization headers. If the dev mode is set to true, then we don't need authorization. By that, we mean that we don't need a URI to get started with DataBridge, and we can just connect to our local DataBridge at port 8000. The completion model for now will be using Llama, but we have an option for using OpenAI. And then we have a few default parameters like the model name, how many max tokens, what temperature we want to use, and where it'll be hosted. In case you're using your own local Llama server, you'll be hosting it at localhost 11434 or wherever your Llama server is hosting. But for Docker, we host it at this URL. We also have it so that our database is Postgres. The embedding model we use is Llama with nomic embed text. We could swap that out very easily to OpenAI. Now we use an unstructured parser. For now, we have re-ranking set to false. If you set re-ranking to true, when you retrieve documents or chunks, we will re-rank them based on the query in terms of relevance so that the answers you're passing to your query model are much more relevant. The storage parameter we're using for now is local storage, but you have the option to store it on AWS as well. The vector store, because we're using Postgres, we're using PG vector. We have the option of using MongoDB as well. So now that we have it running on 8000, let's connect to a shell. Because we're running in dev mode, we don't need a URI. Otherwise, here you would need to add in your URI after shell. It's just an argument. Right, so now we're connected to DataBridge. Let's try and ingest a first text document in DataBridge. As we can see, we get a return as an object. It tells us what the external ID is. This is where the whole document representing this text is saved. It'll have various things like metadata, the file type, file name, where it is stored. So because this is plain text, it doesn't have any storage info. We'll see when we insert a proper file that it does have some storage info. Let's try and query our API. Super simple to use. Let's do what is DataBridge. This should get the relevant documents, which in this case is one single chunk, and pass it to our LLM to help answer the query. Right. Nice to meet you. As per our context, DataBridge appears to be a powerful blah, blah, blah. In terms of the context we provided, it generated a certain answer. You can use different LLMs. We're using Llama 3.2. If you were to use OpenAI GPT-4 Turbo, maybe you would get better results because this is a tinier model that we're using. So yeah, that's how easy it is to ingest a text. Now let's do something cooler and try to ingest a file. Let's just ingest the README document. There you go. README. It also takes in file name, and this file name will save the file as that file within our system. So let's just call it README as well. Let's take a peek at a README to see what kind of questions we can ask it. So README has information about core features, something about endpoints. The document has been ingested and chunked into 6 chunks, depending on your chunk size, which you can change in DataBridge. Let's try and query this. We can see that maybe the model is not as good, but it gives us a response and it definitely reads me.md file because it gives us information about checking the API reference or quick start guide, which was not mentioned when we initially ingested the text. Let's try to ask it about core features. There you go. That's much better. It tells us about the core features of DataBridge from right here. It includes document processing, semantic search, interactions, and so on. It has an extensible architecture, modular design, looks like a very promising system. Other than just the shell, we also have a UI component that you could use. It's super easy to use. So you CD into the UI component. Because we're running it for the first time, we need to install the required dependencies. So we run npm install. It'll take a while. Then we just start the server somewhere. So it runs at localhost 3000. Let's jump to it. Nice. For the UI component specifically, we need a URI to get started. So let's see how to get the URI. We go to localhost 8000 docs, which just exposes the fast API endpoints. And we have this utility function which helps us generate a local URI. Let's click on try it out and execute. There you go. We get a URI right here. The URI contains information about what we're connecting to, what user we are. It has an access token. So if you're running applications in production, you would want to have a super strong JWT secret key. Based on that, it'll configure your token and where to make requests to. So let's go here, connect to a server. We already have 2 documents because we inserted 2 documents. Let's try and insert a new document. I have this document about RAG systems, which has information about what a RAG system is and the various approaches in a RAG system. Let's try and ingest this document using a UI. So let me do add source and click on RAG. We can check our server and see that it starts creating many embeddings for that document. It's a large document, 30 pages or so. Once it's done, we'll get a good to go response and the UI component will stop loading. By the way, all of this is running locally. We're using Nomic embeddings for it. So there's no cost to you, just your compute on your laptop. While this is running, let me quickly go and grab my OpenAI API key to show you how easy it is to change a LLM model to something else like OpenAI. Oh, nice. It has generated around 209 embeddings, 209 chunk objects, and it stored the document at some location. That location is in the storage file. If you look here, we'll be able to see a RAG document. So let's query it. The paper talked about modular RAG. So let's query something like what is modular RAG and what are the components involved. Super simple query. Hopefully it uses the context and gives us an answer. If we go back to a server, we can see that it finds 3 authorized documents related to that. It found four similar chunks, and then it returns those chunks to our LLM. And then our LLM sort of uses that chunks. You can see over here what chunk result we get to answer the query. There you go. We get our answer. That is pretty precise because it talks about modular RAG based on what the document talks about. This looks super promising. It also talks about naive RAG and advanced RAG, and it starts comparing these techniques. So as you can see, that shows how well the embeddings are created, that even for a small model like Llama, it responds with such a good answer. Now let's see if we can change our completion model. For that, let me Control C and stop running this server and do Docker compose down to tear down all the various containers. My containers have been removed. And then let me go to DataBridge Toml and change the completion model from Llama to 4.0 instead. So this will use GPT-4 Turbo preview. And then one thing that I need to do is have my .env information about the OpenAI API key. So this is the API key that I copied. I paste it here, and then I am good to go. That's it. It's super simple to get started with. And then I can do Docker compose up, and we'll have to build it again because we're changing the key. Nice. It does the setup in the background. And because everything is persisted locally, if we hit connect again, this should connect successfully. Let me ask it the same question and see how GPT-4 Turbo performs on this. There you go. GPT-4 Turbo has a much better response model where it gives me each point like that, and it uses the context much more properly, understands my query properly, and it's super simple to get started and switch to different models. So there you go, a very simple getting up and started with DataBridge. Please let us know any questions, feedback, concerns. We always welcome contributions to our repo. Go ahead, give it a try, give it a like, and share your thoughts. Thank you.